Welcome to our final week. We've taught our robot to feel, see, and find itself. Now it's time to teach it how to decide. How does a robot take in all that raw information and turn it into one clear choice? This is the final act of the Sense Plan Act cycle, where a robot listens to a symphony of senses to act intelligently. Before any decision, the robot needs input. Ultrasonic measures distance. Line sensors read the floor. The IMU keeps balance, the microphone listens for your voice, and Lidar builds the full picture of the room. Each one contributes a note. Together, they create awareness. The first stage of the cycle is sense. A robot must first gather and trust its data. Remember the drift problem from our previous episode on SLAM? That's where the Kalman filter steps in. A calm, wise guide that listens to every sensor, filters out confusion, and produces a single, confident picture of reality. Think of it like the robot's quality control advisor. That clear signal becomes the foundation for every decision that follows. This is what the robot uses to make its final choice, and it is the output of the sense stage. Fusion isn't just for robots. We do it too. When you cross the street, your eyes judge the cars, your ears listen for sirens, and your inner ear keeps your balance. You merge all that data in a heartbeat to decide when it's safe to step forward. That's sensor fusion, the art of many signals becoming one smart choice. For a self-driving car, decision-making is life or death. It fuses inputs from cameras, Lidar, radar, and IMU to form a 99.9% confident view of the world. That confidence, that clarity, is what lets it accelerate, brake, and steer safely. Decision code needs wisdom. Not every sensor is equally reliable, so we give more weight to stronger data. If Lidar's 90% reliable and ultrasonic only 60%, the robot learns to trust the Lidar more. Just like we learn to trust experience over rumor, robots learn to prioritize accuracy. The final stage is the act stage. This is where decisions come to life. But even here, priorities matter. The plan can change instantly. We use code to create an override. For example, Lilybot might be on a task following a line, but if the code hears a voice command, like stop, that external human input immediately takes over, overriding the current task. That's the mark of intelligent design, knowing when to pause and when to let new input rewrite the plan. Robots and humans share the same principle. Wisdom comes from awareness. Whether it's a line sensor or a life decision, the goal is the same. Listen, interpret, act, adjust. Intelligence isn't just about knowing, it's about responding with understanding. We've reached the finale, the complete Sense Plan Act cycle. Let's think about this. How would you program your robot to use its sensors? Sense. Decide on a path? Plan. And then stop for an obstacle? Act. Remember the fundamentals of a deliberative cycle. The robot senses its world, plans its path, and acts with intention. Sensing leads to planning, and planning leads to intelligent action. That's the heartbeat of autonomy. You've just completed the Sensor Subsystem Series. Thank you for following this series. Tune in for our upcoming build month where we explore the actuator system, the robot's muscles. Watch all previous episodes and visit our website STEAMDivas.org for more lessons, downloads, and community challenges. Be a part of something amazing. Remember, the future of robotics is waiting for you to build it.